So in order to demonstrate that order matters when performing transformations of functions, I just want to show you what happens when we do it incorrectly. So let's say I have this parabola G and I've applied some kind of vertical and horizontal translation to move the vertex. At this point in time, my graph is completely congruent to, meaning it's exactly the same size as the parent function. But when I actually go to reflect it along the line y equals 0, as we saw at the beginning of our lesson, it's going to take into account this offset. So now if I were to say reflect it and stretch it by a factor of -2, okay, it's actually going to be 4 units from the x-axis in the negative direction. So this is actually the incorrect way to reflect a graph. If you first move the vertex and then reflect, you're creating an offset. So let me show you what that one should have looked like. Because if we were to apply these transformations correctly, the first thing we should have done was taken our parent function, x squared. The second thing we would have done is multiplied it by -2, reflecting it, and then we would have taken all these points and translated them to the left 1.5 units and up 2 units. So it's really, really important that we always reflect first and stretch first. That's the same operation. And then we perform our translation after that. Excuse me. So that brings us to the last part of our lesson, which is now translating graphs and objects using 5-point mapping. So basically, the point I want to get across here is that what we're doing is we're mapping our points x, y to new points x prime, y prime. And the way we have to remember to do that is we apply a to our y values, our vertical values first, and then we add k to them. And for our horizontal values, we take our x values and we apply h to them by adding to those values. All right, so let's do a quick example. We're going to use point mapping to draw the following graph after it undergoes the following transformations. So we have a vertical reflection and a vertical stretch by a factor of 2. So that tells me that a equals -2. What's our horizontal? Okay, so we also actually know that it doesn't move up, so k is 0. And our horizontal translation is that h is +3. It's going to the right. So if we want, we can just write down our points. Okay, and we know all of our new x values are going to be x plus h, and we know all of our new y values are going to be a times y plus k. So our x values are going to be x plus 3, and all of our y values are going to be -2 times y. So if I just translate my points this way, okay, all of my x values are going to be x plus 3, so I get -3, 3, 5, and 0. And all of my y values are just going to be -2 times my initial y values. Okay, so let's graph this. Okay, so it does look vertically stretched. It's skinnier and taller, and it has been reflected definitely, and it does look like it follows all these transformations. Very good. Let's try the next one. So again, a sinusoidal wave, which is fine. So let's look at all the translations that we've been given. Okay, so here we have a horizontal shift. So I know that my h value is -1 because I'm going 1 unit to the left. It's also telling me I have a vertical compression by a factor of 1/3. So what that means is a equals it means that A equals 1/3. And we have a vertical translation 4 units up, which means that K equals 4. So again, going from x plus h to get x primed, and y primed is ay plus k for all of these values. Now, what values do I take? So what happens here is, what I typically do is I find my own nice values. So I can see that I have 5 of them here, and the reason I only need 5 is because if I just plot them for this cycle, I can see that all the other things are just repeats of this cycle. So I'm going to call this A, B, C, D, E. So for this question, I want to do something slightly different. I want us to try doing this in a table. So what I'm going to do is I'm just going to write down the points that I'm given, x and y. So from here, what I'm going to do is apply my transformations in a table. So to go from x, what I need to do is I need to subtract 1, because I know x prime is x minus 1, because I know h is -1. So all I do is I subtract 1 from all of these values. And then I'm going to actually add another column here. So at first, I want to multiply by ay. I know a is 1/3, and I know 1/3 times 0 is 0. 6 times 1/3 is 2, 0, -2, 0. And then to get ay plus k, what I want to do is take this value and just add 4 to it. Okay, so now what I can say is that in the end, I know my a value 0, 0 has translated to a prime, which is -1, 4, which I'm getting from here and here. So there you have it, 5-point mapping, and then we can extend from there. So based on how we've learned how to do our transformations, we can really do any function, but what I need you to get out of this unit is only really just how to be able to do this with quadratics. So let's consider this function. F of x is -2, x minus 1 squared plus 4. We're going to state the transformations. So number 1, we know that it has a vertical. It's vertically reflected, and the reason I know that is because a is -2 and the value is negative, so I know it's going to be vertically reflected. I also know it's going to be vertically stretched by a factor of 2. Oops. Okay, I also know it's going to be vertically shifted 4 units up, and horizontally, and that's because k is +4, and horizontally shifted 1 unit. Did you say to the left? Because it's to the right, because I know that my h value is 1. Alrighty, so how do I do this? I don't have a graph to start with, but I do know my parent function. So let's use a table for this one. Okay, so with my parent function, I already know all the points I need to know. I just need to put it in a table of values. So what I'm going to do is first, because I know how to do this correctly, first I'm going to apply A So I'm going to take all my y values and multiply them by -2. And then I'm going to add 4. And notice that these are always symmetric. Okay, next. What I'm going to do is move it to the right 1 unit. So I need to take all my x values and I need to add 1 to them. Okay guys, so this is what I have called x prime. And this is what I have called y prime. Maybe that looks better. And I can ask you some questions about this. Like, for example, what's the vertex? Well, you know that the vertex is 1, 4. What's the axis of symmetry? Well, you know that that is x equals 1. What is the range? Well, the range in this case, because it's facing down, -infinity to 4 inclusive. Okay guys, so I want you guys to do the next one yourself and just have a look at the video at the end and see if you got it right.